Thank you. Thank you all for listening, and thank you, David, for coming. So we're going to have a fireside chat with David, who is Dr. David, who is the CTO for LG Innotek. Dr. David is a recognized leader in laser and sensing technologies, career in Silicon Valley, Korea. At LG Innotek, David runs all R&D, technology strategy. He's responsible for advanced optoelectronic devices, packaging, precision packaging. I would say he was very instrumental in the large-scale development and deployment of the world's first 3D sensor in consumer devices. It's probably one of the biggest things. And I think, to say the least, his work continues to shape the future of optical innovation in both industry and academia. We're very, very honored to have him here with us today on this fireside chat. David, thank you very much for coming.
Thanks for having me.
Absolutely. So maybe to kick it off, one of the things maybe that probably the audience would like to hear is share for us why LG was interested in Lidar and the importance of Lidar in the LG Innotek portfolio, for example.
Okay, let me start off by saying that Lidar technology is neither unfamiliar nor new to LG Innotek. LG Innotek is still making hundreds of millions of laser modules each year. And these laser modules go into 3D sensing and distance measurement, just exactly what a Lidar is. So for us, having a lot of experience in laser technology, precision optics, as well as very ultra-precision alignment, our foray into the Lidar sector is just a natural expansion of what we're already doing. Also, LG Innotek is a significant presence in the automotive camera sector. So obviously being in the camera sector in the automotive side, being able to add a separate modality of sensing is a very important and a core criteria for our product roadmap.
Yeah. I guess one thing to add on that is we see the same thing. You know, we see how Innotek has all of these expertise in delivering such a product in mass volume. We, of course, have seen some of your CES booth, how you have continued to show some of your previous Lidar, and obviously we're very excited to partner with. But maybe jumping up to another area, which is how do you see that partnership with Aeva? Why did you choose Aeva to partner with?
So, as you just mentioned, Mina, that LG Innotek has demonstrated our Lidar technology every year in our CES booth over the past few years. So we have, over the years, evaluated and tested very, very different and a lot of different Lidar technology platforms. And when we were first introduced to Aeva's technology, what was especially impressive to me was the fact that it was a very elegant solution into being able to bring FMCW technology in a mass-producible manner. I think there are many FMCW companies out there, but I felt that the approach that Aeva has taken was the most practical as well as the most elegant way to move forward at this time.
Yeah. Maybe just something to add, and I guess I mentioned it in the speech as well. When we first started, we actually had to come up with an architecture that we know can be scalable. And there was options and ideas about how to make it more fancy, but some of these were not yet practical. The technology was not available. And that's, I guess, one of the reasons why we had to do this platform, design it in a way that we can go across multiple markets, but more importantly, in a way that we can manufacture it at scale. So, I mean, of course, we're happy that you have seen the same thing, but that's something that I would echo also on our side.
I would like to also add that Earlier you mentioned that you are leveraging proven telecom technology. So, having been in the laser industry for some time, I know how rigorous the telecom laser and transceiver type of technologies need to pass the rigorous tests in reliability and performance. So it was an additional plus that I was using a proven telecom leverage assembly techniques in making one of your key components in your LiDAR.
Yeah, I mean, I could argue there has been billions of dollars invested in the telecom industry. It is no surprise that we would try to use it. I completely agree, and frankly, it is one of the reasons why where we are is that we have been able to use these technologies, these processes for our advantage.
So let me ask you a question here. So what does Aeva see as a potential applications that are additional to what we already talked about today? What other areas are you truly excited about?
I guess there's a couple of areas, to be honest. I mean, obviously, one of the key areas is automotive. I think it touches the safety of people. This is one area that, okay, I'm personally interested in taking all the way through. And I think we are seeing the right interest from our partners, DT and others. And we see that FMCW will play a very key role, like we have seen from Jessica, and how FMCW has the ability to detect the small objects on the road, has the ability to detect this long-range objects, 500 meter plus. So that's one of the areas I would say. Now, I think another area that I touched on, and I think I mentioned in my initial talk, is on the health and biometrics and areas that it is probably not easy understandable what it can do, because this technology has the ability to measure down to microns, vibrations, completely remote, meters away. You don't know yet what is possible. And with the ability to integrate this in a much smaller form factor, put it in robots, these are things that I think it is unclear yet what it would be. But I think the opportunity is massive, frankly speaking. And this is one area that I'm personally very excited about.
You just mentioned robotics as one of the possible applications, and from LG Innotek's perspective, all the sensor modalities that are needed for autonomous vehicle is identical as what needed in making autonomous robots. So they also need to be aware of their surroundings. They need to be able to sense small objects. All the things that I was working towards in the automotive sector, I think is almost directly applicable in the robotic space. And LG Innotek is particularly interested, and we are excited about our potential collaboration in that sector as well.
Yeah, good to know. Maybe something question from my side here is, as you are focusing on your large market presence, your focus on scale, your capability, what is the critical focus for the future technology in sensing, hardware, and software?
So obviously, given our very large presence in the camera sector, being able to make hundreds of millions of modules each year, what we really are driving towards is a marriage of multimodal sensors, meaning that in addition to cameras, we need to have complementary and supplementary technologies that can support the shortcomings of camera-only approaches. So having a multimodal sensor solution that is added with the perception software, I think that is the major direction that every maker is looking forward to making, and be able to provide a very attractive solution for potential customers out there. So I think multimodal, I think, is the key word, not only just LiDAR, but LiDAR plus camera. I think this was mentioned earlier in some of the automotive sector as a place of interest. So I think those are the areas that we will be focusing on in the near future.
I guess maybe shift a little bit gears. How do you see the collaboration so far between LG, Innotek, and Aeva? From your point of view, how has it been, and also probably for the audience as well?
So I don't want to get too deeply into technology at this point, but after all, we are CTOs, right? So maybe we should talk about technology a little bit. I'm particularly interested, I'm impressed that Aeva has a lot of in-depth knowledge about laser devices, as well as semiconductor processing. Although on your slides it just says lasers, you and I both know what type of in-depth understanding of semiconductor physics and photonics and optoelectronics all need to come together for you to make your, be able to make FMCW lasers. So I think starting from that aspect is where LG Innotek and Aeva can work together. There's also some what LG Innotek has been developing in terms of our Lidar platform in the past. I think those complemented with Aeva's FMCW technology could be very attractive solution out there. So our near-term collaboration will be focused on marrying existing solutions that both companies have and be able to come up with something that's more than just 1 + 1, but maybe 1 + 1 = 4. That's the type of solutions that we'll be working on.
And I mean, obviously we have talked about both of our roadmaps. It is going to be very critical in the long term as well as in the short term, how to marry both of these. And maybe one thing to add on the collaboration side, we have multiple projects we're already working on. We're going to be releasing products very soon that is based on these collaborations. We have a couple of products, and more importantly, we have customers interested that we are both talking to that are seriously interested in both of these applications.
Just so that the audience knows that we actually, LG Innotek engineers are working jointly with Aeva's engineers on site. So in your Mountain View office, we have dispatched our engineers and they're working side by side. And we would really much on track, we like to be on track to be able to show the world of something of our collaboration, and sometimes in 2027 is what we can both expect.
Maybe one other question I have, and I'm sure the audience would like to hear, is how do you see the path for Lidar, and how would it go towards commercialization? How do you see that in the future?
So I think earlier, one of the Aeva's presentation mentioned that Lidar, maybe 5 to 10 years ago, Lidar was something that was an R&D project. It was something that works well in the lab, but doesn't work that well in the real world. I think Aeva's changing their paradigm on that. I think some of your real world application is showing how practical Lidar technology can be. So moving into the future, I think we can imagine the world where Lidar technology goes into devices that we haven't even imagined yet. Earlier you mentioned a topic on that, and I would like to add that with the advance of physical AI, now the world is trying to understand the world in 3D and be able to map that 3D world into the physics world. So I think for the physical AI aspect of it, we can start imagining many more devices and many more applications that uses a high precision 3D mapping of the world and how that can be fed into AI models that correctly describe the kinetics and other aspects of physics. And that will enable new classes of products. And I think that's the direction that I believe you and I, when we compared our technology roadmap, I think we saw commonality in that type of ambition that we have. And I think that's the aspiration that everyone in this field should look forward to having.
I completely agree. And with that, I think, thank you, David, for coming. I appreciate you coming. And next, we will have Susan, who will come and talk about manufacturing.
Thank you.
Thanks a lot.